So what if I told you that one single piece of land could tell two completely opposite stories at the same time? One is a story of incredible creation, right? Continents slamming together billions of years ago, forging this unbelievably rich foundation. But the other story, it's one of destruction, where that exact same land is being torn apart as we speak. We're going to dive into this geological paradox where an ancient collision basically created a treasure map, and a modern rift is ripping that map right in two.
You're looking at one of the most geologically active places on the entire planet. What we've got here is a tense standoff between three massive tectonic plates. You have the Arabian plate up north, and then the African continent itself is splitting into two new plates, the Nubian and the Somalian. But here's the thing. They're not crashing together. They're pulling apart. And these immense forces are creating a brand new ocean right down the middle, the Gulf of Aden.
So, what happens in a tectonic tug-of-war like this? Well, the Arabian plate is just peeling away from Africa, moving northeast, and it's not stopping. This unbelievable strain is literally cracking the Earth wide open, creating these two huge wounds that are filling up with seawater. You've got the Red Sea, and our main focus today, the Gulf of Aden. These aren't just little cracks. They are the fault lines that are ripping a continent apart. But this isn't some nice, clean break. Geologists have a specific name for it, an oblique rift. And that oblique part is key because it means the land is being pulled apart at an angle. Think about it like this. If you pull a piece of fabric diagonally, it doesn't just stretch evenly, does it? No, it shears and tears in this really complex, jagged way. And that angled tearing is exactly why the Gulf has the unique, segmented shape it does today.
Yeah, because of all these complex forces, the Gulf of Aden didn't just pop into existence all at once. It actually formed through a process called propagation. But a much cooler way to think about it is like a zipper. The tear started over in the east, basically grabbing a piece of the Indian Ocean, and then it just progressively unzipped its way westward for millions of years, heading straight for the heart of Africa. And this timeline, it shows that unzipping in action. You can see the whole process kicked off about 20 million years ago, way out in the east. A few million years later, by 17.5 million years ago, that rip had torn 500 kilometers further west. Then another jump. And then look at the end there. The youngest bit of ocean floor is just 3 million years old, and it's in the far west. It's a clear westward march. The further west you go, the younger the rock is under the waves.
Okay, so things are already pretty dramatic, right? But this isn't just a story of things being mechanically torn apart. We have to introduce another major player here that completely changes the game, the Offer hotspot. Now, this isn't just some volcano. This is a massive plume of superheated mantle rising from deep inside the Earth. It's like a giant blowtorch aimed at the underside of the continent, heating it, weakening the crust, and totally changing the rules of how it breaks. In this chart, it shows just how dramatic the hotspot's effect really was. What it's plotting is the age of the ocean floor against its location, from east to west. So the slope of that line tells us how fast that geological zipper was moving. And for a long time, it was moving at this steady, really incredible pace. But then, you can see it right there, around the 45-degree longitude mark. Something changed. Big time.
Get this, for the first several million years, that rift was tearing through the cold, brittle continental crust at an unbelievable speed, 120 kilometers per million years. For a geological process on this scale, that is insanely fast.
And then, boom, it's like the whole process slammed on the brakes. As that rift got closer to the land being cooked from below by the Afar hotspot, its speed just plummeted by 90%, down to just 12 kilometers per million years. So why? Well, that hot, weakened crust didn't fracture cleanly like the cold rock did. It started to stretch and deform like taffy, and that acted as a massive break on the rift's journey west.
All right, so we've got this incredible modern story of a continent being violently unzipped. But it kind of makes you wonder, right? What about the fabric itself? What was this landmass actually like before all these forces began tearing it to pieces? And to answer that, well, we have to rewind the clock. Not by millions of years, but by billions.
And this is where Yemen becomes the absolute crucial piece of the puzzle. You see, it sits on this unique geological bridge. It's the missing link where two vastly different, incredibly ancient continental blocks were stitched together, forming the very foundation that is now being ripped in two.
So the two ancient worlds that meet in Yemen are the Arabian-Nubian Shield to the north and the Moزنبيق Belt to the south. Now, think of the shield as new land, geologically speaking. It's juvenile crust, made from volcanic islands that formed in an ancient ocean less than 1 billion years ago. But the Moزنبيق Belt?
That's the really old stuff. We're talking continental crust billions of years old, which was later crushed and reheated and totally deformed in a massive continental collision.
This table really highlights Yemen's special position. If you look north, Saudi Arabia is mostly that younger juvenile crust. But Yemen's a mix. And notice that metamorphic grade? It's got the highest grade, granulite, which tells geologists it was squeezed under the most intense heat and pressure, right in the heart of that collision. And check out the age. We found rocks in Yemen that are 2.7 billion years old. That's a clear signature of that ancient African foundation. And here it is. This is the crucial point. The boundaries where these two ancient worlds collided, they're more than just geological scars. They are, for all intents and purposes, a treasure map. The intense pressure and heat from that continental smash-up created this deep plumbing system that allowed all these valuable minerals to get concentrated right along these specific zones.
The technical term geologists use is suture zones, and is a perfect name, really. Think of them like the high-strain seams where these ancient landmasses were stitched together. And critically, these deep fractures acted like superhighways for hot, mineral-rich fluids to flow up from the mantle and deposit their precious cargo.
And we're not just talking about one kind of treasure. This table gives you a look at the different prizes. Erogenate golds, for instance, you find that directly within the shear zones, the seams of the suture itself. Magmatic sulfides, carrying nickel and copper, are found in rocks that got squeezed into those weak points during the collision. Every single type of deposit tells a story that's directly tied to a specific event in this ancient continental car crash. So, okay, the geological map is there. It's literally written in the rocks. But how do you actually read it and find these deposits? Especially when they might be buried deep under sand or recent lava flows. Well, that's where the modern, high-tech treasure hunt begins. Finding a deposit that doesn't show up on the surface, what's called a blind deposit, is a whole high-tech process. You start from space, using satellites to detect the unique light signatures, or fingerprints, that minerals leave behind. Then you fly planes low, with sensors that can literally see through the sand and map buried faults and rock types. And finally, you take all that data, combine it with drilling info from the ground, and use AI to predict exactly where that hidden treasure lies.
And this is where those two big stories of our region, the ancient creation and the modern instability, really collide. This table shows a pretty stark contrast. Saudi Arabia has invested a ton in mapping its side of the shield, with all the latest technology, from the air and from space. But in Yemen, which sits on the exact same promising geology, exploration is kind of stuck in the past, relying on old legacy data. The modern security situation just prevents the on-the-ground work you need to turn all that potential into a reality.
I mean, this quote from the source material really just says it all. The geology doesn't stop at the border. The rocks in Yemen are a direct continuation of the exact same systems that are proving to be absolutely world-class mineral provinces just to the north. The potential is immense, but it remains, for now, almost entirely theoretical.
And that leaves us with a final, pretty provocative thought. We've seen how ancient collisions created a literal treasure map written in stone, and how modern rifting is tearing that map apart. We even have the technology now to read that map from space. So if the map is there, and the tools to read it exist, what does it really take to finally be able to read that map? Everywhere.